Oi, oi, you filthy swines, get in here. Make sure you like the stream, if you like the stream, and subscribe to the stream if you really like the stream. And let's get on with stuff. The biggest question that I like to ponder is, if you've heard of it before, the idea of the Fermi paradox, where every bit of evidence we have suggests that life should be abundant and that there's a high probability that there is intelligent life out there, but yet we can't see it. There's no evidence of it, and we appear to be alone, which is a shame, or is it? I don't know. But the fact is, if we are to assume that life can become complex and civilizations can bootstrap themselves to be industrial, the one example that we have of this is ourselves. We've seen our own history. We've got some record of what's gone on. We can be debating the accuracy of that record, but we know that we exist, and we exist on a planet which appears to have been pretty stable for quite a long time. For 3-ish billion years. I think the first microbial fossils have been dated to be about 3.5 billion years old. So that appears to be a signature of a planet that's pretty stable. So there's lots of opportunities for other creatures, other beings, not human, in the past to have become more sophisticated. And the question is, have they managed to get sophisticated enough to become spacefaring and to create all sorts of fun gadgets that we seem to be enjoying at the moment? Well, this theory or hypothesis is called the Silurian hypothesis. And this article on medium.com, written by Michael Diodati. I'm not quite sure, sir. You've got a name. It's a good name. The Silurian hypothesis. What geological traces could have left a hypothetical industrial civilization that flourished and disappeared many millions of years ago? Because if you look at the fossil record, there have been very large creatures on this planet for at least 200 or maybe 300 million years from the late Permian, around the Permian time. I mean, the biggest extinction this planet has ever had was during the Permian extinction, where I think about 95% of all creatures became extinct, which is a pretty horrific amount. If you're worried about the negative effects we might be having on life, and you wanted to look for a previous time where there was a species who had some kind of hideous environmental disaster, wiped out all the species around it, it could well have been back then during the Permian era, which was about 200 million years ago, I think. It's just before the dinosaurs, before the Triassic period. Anyway, let's read this. As far as we know, Earth is the only planet on which life has existed and exists. And it's also the only planet known to us to have given rise to at least one industrial civilization, ours. A civilization of this kind, made up of beings capable of using external sources of energy such as fossil fuels or solar energy on a global scale, has existed on our planet for no more than 3 centuries. Its origins date back to the Industrial Revolution, which has provided the means to transform our local economies into a highly integrated system capable of ensuring mass production of an ever-growing number of goods and the ability to alter the environment globally. As members of the only known industrial civilization, we face alone, at least for now, 2 vast immensities, space and time. It's a bit dramatic. Okay. The rapid disappearance of the traces of the past. As far as space is concerned, we know with reasonable certainty that at least from here to Pluto, there is no other industrial civilization, and not even any apparent signs of life outside of Earth. This conclusion is supported by the very large amount of data collected by the many probes that we have sent so far across our solar system. If other civilizations existed beyond Pluto, we can only imagine it, but our ignorance in this regard is total. Of course, we know that there are many, many planets that orbit stars other than the Sun. In just over 2 decades, thousands of them have been discovered thanks to the Kepler Space Telescope and other sophisticated instruments. From the ratio between the number of extrasolar planets discovered so far and the total number of stars observed, we can infer that there are probably more than 10 billion habitable worlds only in the Milky Way. Too many even to count. Really, 10 billion habitable world. What do you mean? How do you grade something as being habitable? Is Mars habitable? What's your criteria there. There is a big issue with them. Those planets are all out of our reach, and by a lot. With the technical means available today, we can at best discover some element in the atmospheric composition of an extrasolar planet not too far from Earth. Next-generation telescopes such as the JWST and the ELT will even detect the presence of any atmospheric biomarkers such as methane and oxygen. And seeing the signs of industrial civilization on planets distant tens, hundreds, or even thousands of light years from us is, for now, something belonging to the realm of science fiction. The only chance to breach this abysmal wall of ignorance would be to pick up an intelligence signal of some kind, which the SETI project has been trying to do for decades, but unfortunately without any success, at least so far. Exploring the space abysses in search of another industrial civilization is therefore an arduous undertaking, but it is equally challenging to carry out the same search through the time abyss even without moving from Earth. We know from fossil records that complex life forms have evolved on our planet since over 500 million years ago. Half a billion there. We also know that evolution does not proceed linearly, but follows a rough path that passes through life explosions and mass extinctions. We also know that many technical solutions to explore and manipulate the environment, such as eyes and wings, have been invented several times over millions of years by entirely different species in response to similar evolutionary pressures. There is then a question to ask, seemingly bizarre but quite reasonable. Is it possible that some other intelligent species existed on Earth in the distant past that created an industrial civilization somewhat analogous to ours? And another question immediately arises from this question: if another industrial civilization ever existed, what geological traces do we have to look for to prove its existence? The second question guided the work of two scientists, Gavin A. Schmidt, climatologist and director of the Goddard Institute of Space Studies, GISS, and Adam Frank, professor of astrophysics at the University of Rochester. Their answer is in a study published in April 2018 in the International Journal of Astrobiology. The title of the article, The Silurian Hypothesis, refers to an episode of the science fiction series Doctor Who, aired in 1970, in which a species of intelligent reptiles, the Silurians, buried by millions of years, is suddenly brought back to life by human experiments on a nuclear reactor. It must be said immediately that the outcome of the research is negative. Schmidt and Frank have not found any geological traces that can be considered a proof of the existence of a past industrial civilization, nor do they believe that such a civilization ever existed. However, it is interesting to follow their reasoning. Above all, it's fascinating to reflect together with them on the immensity of the past geological time and on the rapidity with which the traces of an industrial civilization like ours would be eroded and finally hidden by the constant rearrangement of continental landmasses and ocean floors. In fact, to understand what traces of its existence could have left a possible industrial civilization flourished millions of years ago, the obligatory starting point is to try to understand what traces our civilization would leave if it were to disappear. Either my brain just broke, or that is a grammatically clumsy sentence. Moving on. Strange as it may seem, if nuclear war or natural catastrophe put an end to humanity more or less suddenly, the archaeologist of a very distant future, millions of years away, would not find any of our artifacts and probably not even the fossil remains of our skeletons. Today, the works built by industrial civilization, highways, railways, bridges, skyscrapers, megacities, dams, etc., tower mightily in front of our eyes. The very surface of the planet is widely modified by human activity, with effects visible from space, as shown by satellite photos of towns illuminated at night by electric lights, or those vast territories covered by the geometric pattern of cultivated fields. But the unravelling of all these works on the geological timescale corresponds to a blink of an eye. The oldest territory of a certain extent currently existing on land is the Negev Desert in Israel, which can be dated to around 1.8 million years ago. But complex organisms have inhabited the Earth since an era more than 280 times more ancient. Therefore, the traces of their existence are buried at various depths in sites that are mostly inaccessible and unknown. If the human species disappeared tomorrow, in less than 2 million years, erosion and sedimentation, which act relentlessly on the territories currently inhabited, would erase any trace of the cities and artifacts produced by industrial civilization. Maybe so, but if we had a moon base, would that not persist? If we'd put stuff on Mars, would there be, I don't know, the foundations of buildings left over? Maybe. That's a conspiracy theory, though. Considering that urbanized humanity occupies less than 1% of the total Earth's surface, the chances of recovering the buried remains of our civilization in the distant future are reduced to a minimum. Moreover, fossilization is an extremely rare process that depends on many factors, including the climatic conditions and the ratio between soft and hard tissues of the dead specimen. Although we do have a habit of burying our dead, don't we? So we are increasing the likelihood that something might be left over. For example, of all the countless billions of dinosaurs that have lived on Earth for about 200 million years, we own the nearly complete fossils of a few thousand specimens. It corresponds only to a handful of dinosaur fossils for every 100,000 years. For all of the thousands of taxonomic units that existed in those 100,000 years. As a result, the chances of encountering the remains of an industrial civilization that existed millions of years before but only lasted a few thousand years are minimal. So, is it indeed impossible to find traces of any possible industrial civilization of the past? And should we resign ourselves to not leaving any marks of our own existence? Not exactly. If it is true that the artifacts deteriorate very quickly and that the fossils are scarce, however, the global impact of industrial civilization on the climate and mineralogy of the planet remains. The global impact of industrial civilization in the sediments from Anthropocene. So Anthropocene is the era that we are in now, I believe. Millions of years old oceanic sediment cores emerge here and there in various parts of the world. In a sedimentary core, a layer of a few centimeters is deposited on average every 1,000 years. In those few centimeters thick, paleontologists of a distant future could find all that remains of the Anthropocene, that is, the geological era characterized by the influence on a global scale of human activities of the last centuries. Those activities can be reconstructed, albeit very roughly, by analyzing the chemical compounds present in those sediments. What paleontologists of the future would find by examining the thin sedimentary layer from the Anthropocene is, first of all, a sudden change in the ratio between carbon isotopes 13C and 12C. Since the second half of the 18th century, humans have released over 500 billion tons of fossil carbon, previously imprisoned in coal, oil, and natural gas, unearthed and then burned. In addition to this, industrial activities have caused enormous deforestation, causing the release into the atmosphere of large quantities of carbon dioxide produced by the combustion of biomass. All of the carbon from fossil fuels and deforestation is of biological origin. As such, it is low in 13C compared to the much larger carbon mass of inorganic origin existing in nature. Therefore, a consequence of human industrial activities is that the amount of 13C isotope compared to 12 is rapidly decreasing in the atmosphere, oceans and soils, with a percentage of change that at the moment is around 1% lower compared to pre-industrial era. So it's called Suez effect. Okay. So there's different types of carbon that have been deposited, and one is industrial, the other is not industrial. Gotcha. The release into the atmosphere of large quantities of fossil carbon and other greenhouse gases such as methane and nitrous oxide caused the average temperature of the planet to rise about 1 degree C since the middle of the 19th century. The paleontologists of the future could find traces of this change too, examining the concentration of calcium carbonate in the foraminifera included in the Anthropocene marine sedimentary layers. This concentration could be increased due to the higher amounts of CO2 dissolved in the oceans with consequent acidification of surface waters. So many big words. Another significant global change due to the spread of industrial civilization originates from the enormous amount of nitrogen introduced into the waters of rivers following the use of fertilizers in agricultural activities. The presence of large quantities of nitrogen favors the proliferation of microbes in the coastal ocean waters, which leads to the decrease in dissolved oxygen in the water column. This process creates anoxic regions in the ocean with a progressive increase in the so-called dead zones. These zones will be identifiable in Anthropocene sediments through their higher organic content and lower bioturbitation, the alternation of deposits due to the activity of living organisms. The mining activities necessary to support industrial civilization have also produced an increase in the diffusion of lead, chromium, antimony, rhenium, platinum, gold, and rare earth elements in the river waters. These elements are now present in concentrations higher than those due to natural cycles. It will alter the composition of coastal sediments, which will show geologists of distant future peak in the concentration of these metals in correspondence with a layer dating back to the Anthropocene. The distribution of fossils recovered by future paleontologists will also be affected by the global impact of industrial civilization and human activities in general. The success and widespread diffusion of our species in recent centuries have been accompanied by the proliferation of highly invasive small mammal species such as mice, rats, and cats, to the detriment of many native species that have gradually become extinct. Oh, well, diddums to you, I suppose. Things move on. The total disappearance of the megafauna existing in America and Australia at the end of the last ice age is another of the immediate consequences on geological level of the human species demographic explosion. Therefore, the extinction of many animal species in the face of the widespread diffusion of a few others will be what Anthropocene fossils will testify, if and when they are brought to light by paleontologists of a hypothetical future civilization. Well, the disappearance of the megafauna is interesting, and creatures tend to grow to the size of their available food source. So the fact that these creatures were so large shows that they had a very abundant diet. The fact that they all came to an end at roughly the same time, which I think is kind of in line with some descriptions of a comet impact about 12,000 years ago during the Younger Dryas. I'm not sure if people were exactly responsible for eradicating these megafauna. And then also, I know it sounds outlandish, but if there's big prey to catch, perhaps there were big humans to catch the big prey. And there are lots of stories of giants and very large people. So maybe there were, in fact, megafauna humans as well back then. There's all sorts of stuff, I think, that we don't know, hidden beneath the waves. I've said this before and I'm saying it again. Finally, we must not forget industrial chemical products which are very resistant to degradation spread worldwide today. Compounds such as polychlorinated biphenyls, the notorious PCBs, chlorofluorocarbons, CFCs, and synthetic steroids, if found in the sediments of our era, could be considered by future scientists as unequivocal evidence that there was an industrial civilization and that created them with synthetic processes. However, we do not know how long these compounds can survive degradation by chemical, photochemical, and biological processes, and if they would still be recognizable millions of years after their production. However, plastics could withstand for a very long time if incorporated in highly resistant aggregates of waste that came into contact with high temperatures known as plastiglomerates. So, plastic melted down into a lump. Basically, if you've seen any landfill, then you'll know when they throw a layer of dirt over the top and seed some grass, it may look like a beautiful grassy hill, but I've seen a few former landfill areas and they have these big gas pipes dotted around to allow the escape of gases that are accumulating from whatever matter was hidden underground, rotting. But these landfill sites are concentrations of oddities. So you'd think if there was an ancient species that was advanced to a certain degree, they would also have similar waste disposal problems and there would be concentrations of waste. We found it in many excavations of much more recent settlements. So, some of our landfill sites are pretty gargantuan, and I wonder, they would be quite persistent. I don't think they'd necessarily disappear. If they disappear, I mean, they'd be buried, but, the contents of them would still be odd millions of years from now, I imagine. Lastly, the transuranic radioactive elements remain. If humanity were to destroy itself through a nuclear holocaust, unlikely in my opinion. Some isotopes of elements that can be used to produce atomic weapons have such a long half-life that they could be detected even after several million years. Plutonium-244 and curium-247 in particular have a half-life of 80.8 and 15 million years respectively. In summary, if the current industrial civilization were to disappear from Earth's face in a few centuries, all that would remain in the distant future of its activities and its very existence would be the traces incorporated into Anthropocene sediments of the planetary pollution it has, we're calling it pollution, are we? Has caused in a very short geological time. Traces originated by the release of vast quantities of carbon of biological origin into the environment to produce energy, global rise in temperature due to greenhouse effects, the alteration of the nitrogen cycle, acidification of the oceans, and blah blah, the extinction of numerous animals, yes, peaks in the diffusion of rare metals for industrial use, and possibly isotopes of radioactive elements used for the construction of atomic weapons, synthetic pollutants such as PCB, CFC, and plastic minerals. Blah blah, yes, blah 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 blah. Are there geological traces of industrial civilizations that lived in past eras? Well, I'm guessing no at the moment, but, keep looking. If this list contains all that an industrial civilization like ours will leave behind in the Quaternary era sediments, we can consider all these traces as geological markers. In their presence, it is fair to ask whether they are the testimony of the passage of Earth of other industrial civilizations before ours, created by non-human species long since disappeared. The Silurian hypothesis at the center of Schmidt and Frank's study is based precisely on this attempt. It is the search for geological traces of events that occurred many millions of years ago. Such events exhibit characteristics mostly analogous to the traces that our industrial civilization could leave in sediments from the Anthropocene. Moreover, they cannot immediately connect to natural catastrophes such as impacts of asteroids and comets or mega volcanic eruptions. The first event reported by Schmidt and Frank is the Paleocene-Eocene thermal maximum, or PET-M, that occurred about 56 million years ago. PET-M lasted between 100 and 200,000 years and was characterized by an average rise in temperature between 5 and 7 degrees C. In less than 5,000 years, a large amount of carbon of unknown origin was released into the environment, causing a negative peak in the ratio between the carbon isotopes similar to that produced today by human industrial activities, but more pronounced, with a percentage of decrease of 13C isotope higher than 3%. Besides the abundance of many metals including vanadium, chromium, zinc, and molybdenum spike in sediments dating back to PET-M. So that's an example where maybe 56 million years ago there was a sudden rise in temperature in CO2. Okay, is that not maybe a suggestion that there may be something going on there? I mean, 56 million years ago, it's not that long ago compared to the entire history of life on Earth. As far as I'm aware, 3.3 or 3.5 billion years ago is the oldest discovered fossils. So, yeah, if we are going to agree that these oils or whatever are the result of old, ancient life, I'm not so sure. I like to play with the idea that perhaps oil is a byproduct of subsurface bacteria. But I mean, I'm not an expert. I just think there's a lot of biomass underground, and that seems reasonable to me. I don't know. What do I know? I know nothing. Over the next 6 million years, other hypothermic events with similar characteristics occurred, with which geologists collectively called ELMO, Eocene layers of mysterious origin. During the ELMOs, there were global increases in temperatures, a decrease in the ratio of carbon isotopes, and anoxia peaks in the oceans. MECO, Middle Eocene Climatic Optimum, another event characterized by a sudden increase in temperature and change in the ratio between carbon isotopes, dates back to 40 million years ago. There are also many oceanic anoxia events, or OAE, of which traces have been found in sediments studied by geologists. These events are even more distant in time. They occurred between the Jurassic and the Cretaceous, between 183 and 93 million years ago. Finally, there are large mass extinctions linked to global climate change, characterized by rising temperatures, deforestation, fires, and oceanic anoxia. From this point of view, the three most important events are the late Devonian extinction between 380 and 360 million years ago, the late Carboniferous extinction around 305 million years ago, and the most severe of all, the end Permian mass extinction about 252 million years ago, which wiped out about 95% of all life, I think. It's pretty catastrophic. Whatever happened back then, it was not a small thing. Something very bad happened to Earth. In conclusion, the study of sedimentary stratification provides numerous examples of past epochs of Earth's geological history in which conditions similar to those created by the impact of human industrial civilization on the environment occurred. These clues concern a global increase in temperatures, a decrease in the ratio between carbon isotopes, alterations of the nitrogen cycle, oceanic anoxia events, deforestation, mass extinctions, cats and dogs living together, peaks in the abundance of some metals. However, none of these geological traces can be considered conclusive proof of the existence of an ancient and vanished industrial civilization. There is no way to prove through the study of sediments that the past climatic global changes of which there is an evident trace have been as rapid and sudden as those caused by human industrial activities. In contrast, events such as Pet M and Elmo seem to have developed over thousands of years, suggesting that they were caused by natural processes rather than the productive activities of an intelligent species. Yeah, maybe. It all depends upon how accurate your records or your measurements are and what kind of civilizations there may have been. I don't know. Maybe that's not true. Maybe there was a species of dinosaur that was very flatulent and that increased so much carbon in the atmosphere, and they weren't that smart. They were just farting lots. Maybe that's entirely possible. In fact, I think that happened. Since Carboniferous, which is around 350 to 300 million years ago, there have been enough fossil carbon reserves to fuel industrial civilization activities like ours. About a third of a billion years of fossil fuels, but the events in which the release into the environments of large quantities of fossil carbon altered the ratio between 13C and 12C isotopes could have entirely natural causes, such as volcanic and tectonic activity. There's no way to prove the artificial origin of those events. Furthermore, it must be considered that a truly evolved industrial civilization must reduce its environmental impact if it wants to guarantee acceptable and lasting survival conditions. Thus, we arrive at the paradoxical conclusion that the more an industrial civilization has evolved, the less geological traces it has left in the sedimentary layers. Exactly. We're obsessed with net zero, and by doing that, we're going to remove any chance that anyone's going to have any record of us because everything will be recycled. If, for example, in the distant past, an industrial civilization capable of supporting its production activities employing ecologically clean energies such as geothermal, blah blah, boring yawn, solar and wind had existed, it would have left a geological trace in the ratio between carbon isotopes much thinner than what we are producing today, through our extensive and persistent use of fossil fuels. In short, time turns out to be an equally unfathomable abyss as space. Several industrial civilizations created by species of which we are doomed to know nothing may have existed in the geological eras. In the end, all that remains of past events is reduced after millions of years to some rare fossil and thin layers of sediment composed of minerals whose relative abundance can only provide vague and ambiguous information on the era that produced them. That's an awful lot of windy blah blahs going on in this article, but the core point is sound, and I think this is pretty interesting. If we consider Earth as being a very active planet and any trace of our existence may be buried and changed so much in the future that you wouldn't be able to tell we were here. If we managed to get off planet and build bases here and there, I think those might last a little bit more. I think there might, if there were other previous civilizations that were spacefaring that could get off the planet, I would be checking the moon for any evidence there. Because if that giant rock has been hanging in the sky above us for millions of years, all of the species of Earth would have looked up there and gone, oh, perhaps we should go up there first. Build a base. Maybe there are ancient dinosaur-derived cities on the moon. I don't know. But I think looking for traces of these things on Earth may be unrealistic, but finding them in space, finding them in the asteroid belt, finding them on all of these moons around Saturn and Jupiter, and I wouldn't be surprised if we find a lot of evidence out there. And fixating on finding them here, it's not so realistic because things just churn over so much. I mean, if you look at another planet like Venus, who knows what happened to Venus? Maybe Venus was a lush planet with an advanced species on there, and they had some kind of runaway greenhouse effect from their industry, and it completely trashed the planet. Who knows? That's a nice story. But nothing of any relevance would exist on Venus for us to see now, because the pressures are so high, it's so hot, everything would melt and be burnt and completely eradicated. You need to look in places where things are much more stable. So further out, perhaps the asteroid belt, perhaps the moons of Jupiter and Saturn, perhaps our moon. Look for interesting, stable places. Look at the poles, I'd say, of Mercury. Any area on Mercury which would be perpetually in shade would be a place to look. If anybody or anything wanted to put some kind of device to keep its eye on the sun, who knows? But probably not going to find much down here. It's all too busy. It's far too busy down here. It's too much life eating each other and bonking each other down here for anything to last for any decent amount of time. But I think it's very likely that there were previous species that were very, very smart. And most of my interest kind of lies in the idea that there was human civilizations tens of thousands of years ago, but it's not out of the question that there were other earlier hominid species that were clever enough to have industry, and there were perhaps other dinosaur-based species. Who knows? It's very interesting. I find it fascinating. But that is it for now. Make sure you like the stream, share the stream, wave at the stream, say kind words to the stream, tell your family about the stream, and what else do I have to say? There's nothing to say, except Pigwig out.
Oink, oinkity, snort, snuffle, snuffle, squee, oink, oink, wee, squeal, snort, snort, oinkity, squee. Oink, 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 squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 wee, 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 oh. Snort, snuffle, oink, squee, squeal, wee, snort, oinky, oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, 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 squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 wee, 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 oh. Oink, oinkity, snort, snuffle, snuffle, squee, oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, 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 squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 wee, 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 oh. Squeal, squeal. Snort, snuffle, oink, re, squeal, re, snort, oinky, oinkity, oink, 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 snuffle, re, squeeze, snort, oink, squeal, oink, oink, oinkity, squeeze, squee, re, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 re, 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 oh. Squeal, squeal, snort, snuffle, oink.